In this lecture mode, we will provide you answers to the following questions. What are the key city logistic improvement schemes currently being used? How are they organized in practice? And, looking forward to the future, what are the challenges we expect our city will face, and what are the game-changing concepts that will deal with these challenges? But before we start to work on the improvement scheme, we need to identify the typical city logistic decision makers, such as shippers and receivers as the ultimate actors who define the freight transport demand. Shippers are usually providing the goods while the receivers are using them for their own consumption or businesses. One type of receivers are, for instance, the retailers in the city center. Logistics service providers and freight carriers are those who are actually responsible for providing the transport and the logistics services to fulfill the demands set by the shippers and the receivers. Finally, we have the residents and the public authorities. The public authorities represent them and are tasked with managing public infrastructure. Urban residents are often the reluctant victims of traffic impacts from passenger and freight transport. Public authorities use their regulatory competence to implement policies that can reduce these effects on behalf of the city. Historically, we observed that the public authorities often took the initiative to initiate this city logistic improvement scheme. In the early days of city logistics, there was a clear distinction between approaches of the civil engineers, who had a background in traffic infrastructure management, and the logistics engineers, who had a background in the management of supply chain. Both disciplines show a kind of blindness to the separate approaches instead of an integration of both approaches. The traffic engineers mainly introduced measures that restricted the traffic in terms of constraints on vehicles or access time windows. Vehicles can be restricted according to weight or length or perhaps by emission standards. Traffic in general also can be restricted according to the time of the day to reduce the pressure of the traffic congestion at certain periods of the day. Traffic engineers also have developed measures which manage specific infrastructure, such as dedicated lanes for freight transport or allowing freight vehicles to use the dedicated public transport lanes. On the other hand, the logistics engineers mainly came up with consolidation principles and ways to optimize their resources. Consolidation reduces number of freight trips, for example, through an urban consolidation center or cross-docking areas located outside the city center where the freight is bundled. In the book on city logistics modeling, Taniguchi, Thompson, Yamada and Van Duyn explain the need for integration both disciplines as a necessary condition to achieve the full positive effects of these new initiatives. Unfortunately, the message was mainly understood by the city logistics researchers and not by the real decision makers. A clear example of showing the need for an integrated approach is explained by Hans Kwak in 2008, who studied the effects of time window constraints in cities to force the consolidation of urban freight transport. Instead of reducing the freight traffic in critical periods of the day, it actually worked the opposite direction. In fact, the use of time window constraints led to an increase of more than 10% of the distribution cost and emission, because the freight carriers needed more vehicles and freight trips to deliver at almost identical time windows in different cities. Nowadays, we can see both in practice and research development of cutting-edge city logistics measures, such as underground city logistics systems, intelligent loading facilities, off-hour deliveries, or even the use of light electric vehicles, that an integration of both disciplines is absolutely required. For the future logistic measures, we will see that integration of ICT is a fundamental domain to integrate for the city logistics engineer. So this is the end of our introduction into City Improvement Scheme. I've shown you what will be the main content of this module. Enjoy it.